Have you ever noticed that people speaking Spanish sound like they're talking really fast?
Para aquellas personas poco familiares con un idioma, el parlante siempre aparenta hablar demasiado deprisa.
Does this mean they're able to communicate information faster than English speakers?
Una de las razones por las que el español
One reason why Spanish sounds so fast is because more syllables are spoken per minute than in English. However, analysis has shown that each Spanish syllable conveys less information than each English syllable, so the information per minute is almost identical. But what about written language? The square format of Chinese characters appears to fit better into our central visual field than the longer, slimmer words of English. This led linguists to suspect that Chinese would be read faster than English. But experiments show that English readers can perceive 7 to 8 letters at once, compared to just 2.6 characters for Chinese. However, those Chinese characters are denser in meaning than the English letters, and so both languages have basically an identical reading rate of 380 words equivalent per minute. This suggests that what limits the speed of our communication is not language, but our cognitive ability to process information. But how can you really quantify information? Well, the smallest amount of information you can have is the answer to a yes-no question. Like, have you seen the movie Frozen? Yes. Yes or no, heads or tails, we can represent this single outcome with a 1 or a 0. One binary digit, it's 1 bit of information. A roll of the dice has 6 possible outcomes, so 3 bits of information are required to cover all the options. To uniquely represent all 26 letters of the English alphabet requires 5 bits of information. But if you include lowercase, punctuation, special characters, and numbers, that takes the total number of symbols to 95. So you actually need 7 bits of information to encode all these symbols. That was first done in 1963 as the American Standard Code for Information Interchange, or ASCII for short. Now, as the next closest power of 2, computers adopted 8 bits as the fundamental unit of computation, and they called it the byte, where they intentionally replaced the I with a Y so that it couldn't accidentally be confused with a bit. So how much information does it take to make you? Well, your entire genetic code is contained in the sequence of 4 molecules, represented by the letters T, A, G, and C in your DNA. Each of these 4 options can be encoded by 2 bits of information. And multiplying by the 6 billion letters of genetic code in your genome and dividing by 8 bits per byte, that yields 1.5 gigabytes of information. So you could fit your entire genetic code on a single DVD with room to spare. Now, your body has an estimated 40 trillion cells in it, and each one contains a full copy of your DNA. So you actually contain 60 zettabytes of information. That's 60 followed by 21 zeros. Just to put this in perspective, by the year 2020, all of the digital information in the world is estimated to be equal to 40 zettabytes of information. You could store all of that on 100 grams of DNA. That is less than you have inside your body. But now consider this. You share 99.9% of your genetic information with everyone else on Earth, meaning that less than 1 part in 1,000 is unique. So the information that makes you, you, could be stored in less than a megabyte. You could put it on one of these, a floppy disk, in case you don't know what that is. In contrast, video can contain a lot of information. To specify the color of each of 2 million pixels 30 times a second for this entire video would require 100 gigabytes of information. But you can watch this video in HD on YouTube with just 1,000th that amount. Now, the reason you can send such a big video with such a small file size is because video, like Spanish, has a lot of parts that are redundant. Hey, Michael, you know what I've been thinking about?
What have you been thinking about, Derek?
Information.
Go on.
It's a physical thing. It's embodied in actual objects.
How's that?
We know, like the words we say. They're actual vibrations in the air, right? They're not just concepts. They are real physical things that you could measure and detect.
That's true, and they don't go away. They don't disappear even after they've, for instance, moved through the air.
Right. After we've said these words, they have actually interacted with everything around us.
So you're saying that technically I could look at the world, and if I knew enough about it and the position of its particles, I could trace back and extrapolate all the information that's ever occurred through them or at them?
That's right. You could, in principle, figure out exactly what we've said here today.
Whoa.
This episode of Veritasium was inspired by the book The Information by James Gleick. And you can actually download this book for free by going to audible.com/veritasium, or you can pick any other book of your choosing for a 1-month free trial. Audible is a leading provider of audiobooks with over 150,000 titles in all areas of literature, including fiction, nonfiction, and periodicals. Now, if you've already read The Information, you may want to check out Surely You're Joking, Mr. Feynman by Richard Feynman. It's my favorite book by a scientist. It is absolutely hilarious. You will thank me for downloading it. So go check it out. I really want to thank Audible for supporting me, and I want to thank you for watching.